Okay, I'm going to talk now to you about finding derivatives of log functions with bases other than e. So the formula for the derivative of log of x, base a, where a is a base other than e, is actually just a product of 1 over the natural log of a times 1 over x. So for instance, if I wanted you to find the derivative of, say, this function here, which is, let me highlight it for you. So if I want the derivative of this function here, log of x base 2, you would just simply say the derivative is nothing more than 1 over the natural log of 2 times 1 over x, which could then be rewritten as 1 over x times the natural log of 2. And that's how simple it is to find the derivative of a log of x base a. Now, it's a little more complicated if you want to find the derivative of log of u, where u is a function of x base a, but you do similar steps. I mean, since the base is a, you would have 1 over the natural log of a, but instead of 1 over x, you'd have 1 over u, and then you would have to use the chain rule to multiply by the derivative of u here. So you'd multiply by that derivative. So if I wanted you to find the derivative of the log of 1 minus x squared base 5, well, the 1 minus x squared would be your u. And so you're wanting to find the derivative of log of 1 minus x squared base 5. You would do 1 over u, so you do 1 over 1 minus x squared, and then you'd multiply it by 1 over natural log of 5, the 1 over natural log of the base. But then you would have to multiply that by the derivative of 1 minus x squared. And remember, the derivative, this derivative here of 1 minus x squared, let me just make a note for you here, that derivative would be minus 2x. So basically what you'd do is you'd multiply this fraction here, 1 over 1 minus x squared times natural log of 5, by minus 2x, and that would just give you minus 2x in the numerator. So you'd have minus 2x over 1 minus x squared times the natural log of 5. Okay? And so that would be your derivative of that function. So anyway, I just wanted to throw in this as a separate video. It's very short, and again, if you like the videos, make sure you subscribe to my channel. Okay, now the next video that we're going to cover involves trig functions. So if you're not in a Calculus 1 course, or a course that involves trigonometry, finding derivatives of trig functions, you can skip. Let me see how many you can skip. You can skip the video on derivative of inverse trig functions. Okay, I said trig. Actually, they're inverse trig functions. So because we've already covered trig functions, so you can skip the video on the derivative of inverse trig functions. And let's see, you can skip the video on inverse hyperbolic functions, and then you can okay, so you can skip all the way until you get to implicit differentiation. And so I have some examples of implicit differentiations that have come up about 2 or 3 videos ahead. So you'll definitely want to see those, because implicit differentiation is a form of differentiation that's covered in basically all calculus courses. So let me see what else. Okay, until you get to the implicit differentiation with trig functions, and those you can skip unless you're in a course that involves trig functions. And then toward the end, I talk about how to find the derivative of a function raised to a function. So that all calculus students will need to see that. And I think that's my last. So that would be my last video on the derivative of trig functions. So I'm sorry, that would be my last video on derivative of functions. So anyway, again, if you just happen to see trig functions and you don't use trig functions in your course, you can skip those. Alright, so I'll see you in the next video if you're a calculus student involving derivatives of inverse trig functions. Otherwise, I won't see you again until I get to implicit differentiation.